Welcome back. This is lesson 8.10 journal. We are graphing inequalities. I will be able to graph inequalities to show all possible solutions. Vocabulary for this lesson. Solution, remember, is any number that can be replaced for a variable that makes a statement true. And an inequality is when we are comparing two numbers that are not equal to each other. So, inequalities have many possible solutions. We can show all the solutions to an inequality by graphing the answers on a number line. All right. I want you to remember this carefully. A filled dot, filled/closed dot, means that a number is equal. An open dot means that the number is not equal. So that's going to be important when you're graphing inequalities, because sometimes we're not equal to that number. We're really, really close to that number, but we're not equal to that number. So looking at this, we know that v is less than or equal to -2. So if it can be equal, that's going to be this sign or this sign, because these can be equal. Open dot is going to be this sign or this sign, because they aren't equal. Simple enough? So I'm going to find -2 on the number line, but because it can be equal, I'm going to put a fill dot. So right on -2, make a dot, but you're going to fill it in. I am saying you are included. I want you. So I want -2. But is -2 the only number that works? Think about all the other numbers that could work to make this true. What's another number that is less than -2? Well, -3 would work, -4 would work, -10 would work, and so on and so on. So we're going to draw an arrow in the direction of all the numbers that can possibly work. Which direction makes this true? Well, -3, -4, -10, all of these are on this side. So how I'm going to show the solutions is that -2 works, and every other number in this direction will also make that true. That's how to show an inequality on a number line. You're just showing me every single number that could possibly work. Now this one says n is greater than 4. Okay, can n be equal to 4? No. So if it's not equal, we want an If it's not equal, then we want an open dot. So I'm going to find 4 on here, but I'm going to make an open dot. I'm saying I want really, really, really close to you, but you're not included. I'm kind of being mean to that 4, but that's what the math says. So I want everything that's really close to 4, but not 4. Now, what numbers are greater than 4? Let's list some. How about 5, 6, 100? All those are greater than 4. So which direction is my arrow going to go in? Everything that is greater than 4. So I'm going to draw an arrow going this way on the number line. 4 is not included, but 4.1 is, 4.0001. Those are all greater than 4, but 4 itself can't be greater. That's why we put the open dot there. So we're saying everything really, really close to this, but not it. All right, let's look at this one. B, open dot or closed dot? Closed dot, because it can be equal. So we're going to find -0.5 or -1/2 on the number line. So -1/2 is going to be between 0 and 1, right there. And we want a closed dot. So let's put a closed dot right there on -1/2. Now, what can B be to make this true? If I put -1 here, would that be a true statement? If I put -2 here, would that be a true statement? No, this has to be larger than -1/2. So, well, which side of the number line is larger? Always to the right. So positive 1, positive 2, everything that is larger than negative 0.5, we're going to draw an arrow in that direction. Okay, open dot or closed dot? Open, because it can't be equal. We're going to find where 1 and 1/3 would be on the number line. Okay, we're going to have to do close guessing here. So 1 is here, 1/3 is just a little bit more, so we're going to put open dot right there. Now you have to decide which side of the number line am I going to draw my arrow, to the left or to the right? Okay, F is less than, so it's got to be smaller than 1 and 1/3. Which direction is going smaller than 1 and 1/3? To the left. Anything to the left of the number line is less. Simple enough. Alright, well, now I want you to think about, if you're given a graph, what inequality could be used. Now we can use any letter we possibly want. It doesn't matter. A through Z, you can take your pick. But what you're comparing it to and how the mouth is facing has to be the same. So, looking at this, open dot or closed dot? Okay, that's an open dot. So does that mean it's going to be equal or not equal? An open dot means that the number is not equal. So I need something that's not equal. Okay, we get to pick whatever letter we want. I'm going to use J, just because I haven't used J in a while. Doesn't matter? No. Okay, J, and I'm comparing it to 2. Now it won't have an equal line. Now I just need to decide what J is. J is all these numbers. So J could be 3, 4, 5, 3.5, 1,000, all the way up this direction. Anything bigger than 2. So which way does my mouth need to be facing so that I am showing an inequality that J is larger than 2? That means the mouth needs to be open towards J. J is everything greater than 2, but not 2 itself. It can't be equal. Okay, once again, open dot. This can't be equal, but we're comparing our variable to 4. I'm going to put 4 here, and I'm going to put what letter. You can pick whatever letter you want. I'm picking Z, just for fun. So, 4 can't be equal, so I'm not going to put a line under it. Now, which direction is this arrow going? It's going to 3, 2, 1. Everything's smaller than 4. So Z has to be smaller than 4. That means the mouth has to be open towards the 4. Now, I want you to realize these are going the same. Look, the mouth is facing the same direction here, but these are going opposite direction. Why is that? It's because of where the variable is placed. I want you to realize that this, I could switch this around and put a 2 here and a J here. As long as the mouth is open towards the J, they're both right. So these mean the exact same thing. I just flipped it around. But the mouth is still saying that J is larger. So, if I wanted to flip this and I put Z first, and then the 4, the mouth still has to be open towards the 4. I'm still saying that Z is the smaller one. Okay? Let's write both for these as well. Now this one is halfway between 0 and 1, so I'm going to say we're comparing to 1/2. What letter do you want to call it? You can call it something different than I do. I'm just going to say A. Now, if it's a closed dot, a filled or closed dot means that the number is equal. So I'm looking for one of these two. So I know it can be equal. I just need to determine which way the mouth is open. So A represents all these numbers on this graph, on the arrow. So where are all these numbers? They are all less than 1/2. So if I want to be less than 1/2, the mouth needs to be facing to the opposite of A. So this could work, or this could work. Both mean the same exact thing. Okay, last one. Positive 1 is what we're comparing with, and I'm going to use the variable D. Closed dot means it can be equal. We just need to determine which way the mouth is open. So 1, it looks like the arrow goes this way, so that'd be 1, 2, 3, 4. That means all these numbers are bigger than 1. That means this D is larger than 1. If we put the 1 first, as long as the mouth is open towards the D, it's correct. It doesn't matter which one you wrote. So here it says, how will you remember? Okay, I'm asking you. This is your own answer. I'm not writing anything. You need to fill it out on your own. How will you remember the difference between when to use a closed dot or an open dot? Write in your own words, take a picture, rate yourself 0, 1, 2, 3, or 4, and turn it in on Google Classroom.